Hi again. Here's another final exam review question. This one from Chapter 7, so Taxes and Taxable Depreciation. And this one's just a kind of a quick question going over the different depreciation methods. And it was actually kind of missing some information, so I added a little bit there. But this is basically 7-9 from the end of the Chapter 7 textbook. And what it's asking for is, what is the depreciation deduction using each of the following methods: 200% declining balance, GDS, ADS, and straight line, for an asset that costs $35,000, so a basis of $35,000. I can write that down. An estimated market value of $7,000 at the end of its 7-year useful life. So it has a market value equal to $7,000 at end of year 7. Okay. It says assume that the macro's class life is also 7 years, and it's actually missing some information here, but it actually is asking for a GDS 5-year depreciation. So although it has a 7-year class life, if you go to, again, provided on the equation sheets for your final exam, although it has a class life of 7 years, its GDS recovery period would be 5. Again, this one's sort of missing some information. They don't specifically tell you what the asset is. In fact, it's not even anything that's actually on this list. But on an exam, I would specifically, indicate an asset that's given to you in the equation sheet. Anyway, on the left side again is the equation sheet that will be provided on the final exam, and the information that's probably needed here the most would be that page I just had, along with this material right here, which are the equations for depreciation for straight line, declining balance, and a reference to GDS and ADS depreciation, which are on the other page. We're going to be walking through the 4 different methods here, and again, some of the equations are given here. Some of them you do have to know how to use. Again, there's no definitions for any terms here, but this question is specifically just asking for the depreciation deduction. So it's looking for DK, and for the second year. So actually, it's looking for D2, D in end of year 2. Okay. So I guess walking down the list, we'll start with 200% declining balance. Okay. All right. And we're going to be looking at these equations here. Again, reminder, D is actually what we're looking for here. D star is the cumulative depreciation up to that year. So if you wanted the depreciation just in year 2, you would use this equation. Same thing with straight line. But if you wanted the cumulative depreciation up to year 2, then you would use this equation here. Right? And if you wanted the book value in any given year, you can follow just this equation. Okay? And so we need to know basically 3 things for these equations. We need to know the cost basis, which was given to us. We need to know the year that it's in, which was, again, given to us. N is equal to K in this case, which is equal to 2. And we also need to know what R is. And R isn't given on this equation sheet. And that's because R can vary based on what type of depreciation you do and for how long the test is, right? Just as a reminder, R is equal to, for a 200% declining balance, 2 over the useful life of the asset. So 2 over n, or 2 over, actually it would be n in this case. If it was 150 declining balance, this would be 1.5. If it was any other type of declining balance, you would, the numerator would be based on the percent declining balance here. So again, this is not given on the equation sheet, so you do have to remember that. If it's 200%, R is equal to 2 divided by the length of the useful life. So I should probably rephrase this actually. So K is equal to 2, which is the specific year that we're looking for, but the useful life of the product, or the asset, is 7 years. Second year. Okay? So in this case, for this asset, using 200% declining balance with a useful life of 7 years, R is equal to 2 over 7. Okay? And so now we can just simply plug that into the D equation and get D for end of year 2. The amount of depreciation in the second year of this project. D2 is equal to the basis times 1 minus R times K minus 1 times R. Okay. And so plugging all that in, is equal to 35,000. 1 minus 2 over 7. 2 minus 1 is the exponent, times, again, 2 over 7. Right? And so the depreciation in year 2 should come out to be $7,142.86. Okay? Just in the second year. Right? Okay. Moving along, looking at the GDS depreciation, right? Which I specifically said was following the 5-year depreciation system. So GDS 5-year, right? As it says here, it just says GDS, see accompanying tables. GDS depreciation is just as simple as multiplying the cost basis by the coefficient. And in this case, this is the 5-year depreciation rate, a 5-year recovery period. So in this case, the depreciation in the end of year 2 is equal to R, little r, in year 2, R just meaning the coefficient, times the basis. So in this case, in end of year 2, it's equal to 0.32. And the cost basis was $35,000. So the depreciation in year 2, following GDS 5-year recovery rate for an object with a 7-year useful life, is $11,200. Just in year 2. Okay. Now going down to the ADS method. The ADS method is actually, again, not on this sheet here, but the ADS method is just the straight line method. Okay. So actually, so we will start with the ADS method. But one thing to remember is when you're dealing with ADS, or using GDS, or anything under macros, we do not take into account the market value. Okay? Under macros, the market value, or the salvage value, or the worth at the end of its life is always considered to be 0. So keep that in mind. For macros, market value, or salvage value, or whatever, at the end of life is not needed. It's considered 0. The reasoning for that is when you're depreciating under the modified accelerated cost recovery system is you always want to bring the book value down to 0. So we're actually going to ignore the $7,000 market value here. Right? Book value must always go to 0. Unless you sell it early, but the trend for the depreciation over its useful life should always end in 0, assuming that the project lasted longer than that. Okay? So in this case, the equation is actually the same as the straight line depreciation thing. It's just instead of putting a salvage value, you're just going to make it equal to 0. So your D in end of year 2 is equal to the cost basis minus 0, right, specifically for the ADS method, divided by the useful life of the project, of the asset. In this case, it's 7 years. Oops. Oh, so I'll just put N, which is equal to, again, 35,000 divided by 7, and the depreciation in end of year 2 should be the same as the depreciation in any other year, is equal to 5,000. Right. And that's the difference between the ADS method under macros, the alternative depreciation system, as opposed to the pre-1986 straight line method, which does take into account the market value or the salvage value at the end of its life. Okay, so this would be pre-1986, and unlike macros, this does take into account the market value. It doesn't actually go to 0, it goes down to its final worth at the end of its useful life. Let's incorporate market value or salvage value. So in that case, you would just use this equation, right? It says salvage value here, salvage value or market value, they're kind of interchangeable. So the depreciation in end of year 2 is equal to the cost basis minus the salvage value at the end of its useful life, where again n is equal to 7, divided by its useful life, 7. So in this case, it's actually 35,000 minus 7,000 divided by 7 years. And D2 in this case is not 5,000, it's actually 4,000. So the big difference between ADS and straight line is just that over the 7 years, under the ADS method, the book value will drop from 35,000 down to 0 over 7 years. In straight line, over that same 7-year period, it'll only drop from 35,000 down to 7,000, and that's based off of its market value. But apart from that, the GDS system will always tend to 0, and 200% declining balance will never actually reach 0. It may or may not reach the market value. It's completely unrelated to the market value. But if you did want to end the 200% declining balance at a specific, say, like the market value or at 0, then you would go with the 200% declining balance with a straight line switchover at some point. This problem doesn't cover that. It just covers each alternative on its own.